Hey everyone, welcome back to another Prepworks tutoring video. Today I'm going to be discussing the definitions of angles, circles, perpendicular lines, and parallel lines. Now, some of this stuff may seem straightforward, but in geometry, you're eventually going to have to do proofs. So this is one of the first subjects where you really have to show your work, and so knowing the definitions of sort of these more basic topics are going to really help you show your work. And really understand, because you're basically applying these simple components of math into larger problems. So yeah, let's just get right into it. So the first thing that I want to talk about is angles. So we have, that's not very good. Let me erase that. So the first thing we have are angles. So what are angles? Well, angles can be formed basically whenever two straight lines or rays or line segments even meet at a common vertex, and angles are basically measured in degrees. So I'll show you an example. So it might actually be more useful for me to show examples of lines. So we have lines, which is basically, a line and goes infinitely in both ways, and it's never ending. And then you're also going to have rays, which is essentially a line. It's very similar, except it has an endpoint on one side, and it goes infinitely the other side. And finally, we have segments. So segments are what you're going to find in closed shapes. So you basically have a line, except the distance between the 2 points is finite, so it ends. So an angle is basically made up of any of these where they meet. And that's going to create a bunch of different angles, and you can classify these angles as acute, right, obtuse, and many more. So I'll show you some examples of these angles. So let's dive into acute angles. So an acute angle is going to be any angle that is under 90 degrees. Then you're going to have right angles. Right angles are 90 degrees. And you're going to have obtuse angles, which are greater than 90 degrees. So these are just some basic angle classifications. And I'll even draw a diagram here just to help better represent angles. So let's say you had two lines. So you have line 1, it goes infinitely in this direction. And then you have line 2, it goes infinitely in this direction. And it's going to intersect and create these angles. So this is an angle here, and this is an angle here, and this is an angle here, and you get that idea. So yeah, and this could be, it doesn't have to be lines. In fact, I think it would be very useful if I showed something like a square. Let's say I have a square here. So a square is made of closed line segments, and it's going to form 90 degrees. So we know a square has 360 degrees, and each of these are going to be right angles. And so you can see how this line right here basically intersects with this one right here. Or I shouldn't say lines, I should really say segments. And it creates this 90-degree angle there. So yeah, let's move on to circles. So circles are quite simple. You can do a lot of complicated things with circles, obviously. But for the purpose of this video, we're just going to draw a nice big circle and just, simply define it. So a circle is basically a closed 2D shape with no corners and no edges. We could say circles are anything like tires, let's say clocks even. So, if this will right. So these could be clocks. Anything of that sort. We basically want to know that it's a round, shape. Moving on. So next up we have perpendicular lines. So these are basically lines or segments that intersect each other at right angles. So let's say I had this line and this line. So these two lines, although it's not proven, but I'm just going to say that they create right angles. So I'm going to say this is 90 degrees right here. And those would be perpendicular lines because they intersect at 90 degrees and create right angles, which are right angles are 90 degrees. And what you'll find is that with other theorems, so this theorem right here is called the supplementary theorem. Not a supplementary theorem, but these are supplementary angles. These are, other topics I'll talk about in other videos. But basically, we know that each of these are going to be 90 degrees in this case, and it adds up because 90 times 4 is going to be 360 degrees. And if you really look at this, let's erase this for a second. These angles are basically a circle. We know that in a circle, there's 360 degrees. So you can see how that checks out right here, which is just really interesting to know. Alrighty, so the final thing for today's little lesson is going to be parallel lines. So parallel lines are basically lines, segments even. Well, I guess you could call it lines. But anyways, it's basically lines. So let's see, I have a line here. That's a really ugly color. But basically, these two lines are going to never intersect, and they're going to be, they're always going to be equidistant at corresponding points. So I think the best way to show this is that basically this line is just going to go on forever, and same thing over here and on these sides as well. And we've talked about what lines are. So basically how you want to approach this problem, or not problem, but basically defining parallel lines is understanding how at corresponding points, the distance between them is equidistant. So if I take a random point here, the corresponding point would be here for the other line. And this distance, which we can just represent as x, and let me take another point. So like, let's say out here, and the corresponding point here, and this distance, let's call it y. This is going to be x equals y. So the distance is going to be the same, which shows that it's parallel, or those are parallel lines. And they're never going to intersect each other because, this can go on forever. And I hope you can see how, if this goes on forever, they're never going to touch. So yeah, that's our lesson today, and I hope you learned something. Thank you for watching.